Take a deep breath before you start lesson 5-4. It can be a little bit overwhelming at first, but if you take it step by step, it will all make sense. During this lesson, you will learn how to convert rates using dimensional analysis, and you will also convert between systems of measurement. The essential question for lesson 5-4 and for all of chapter 5 is how can you identify and represent proportional relationships? In the middle of page 200, you have the definition of dimensional analysis, and it's a process of including units of measurement as factors when you compute. So for example, you know that 1 hour is 60 minutes, and you can write that factor as 1 hour over 60 minutes or 60 minutes over an hour. And in just a second, you'll find out when it is appropriate to use either one of those because they are a big difference when you're trying to cancel out units. So each of those ratios is equivalent to 1 because the numerator and the denominator represent the same amount. So looking at example 1 at the bottom of page 200, we're going to convert miles per hour to miles per minute. So we are going to start with miles per hour, and then we want the hours over minutes so that our hours can cancel, similarly to how we are reducing fractions. We can cross cancel, or we can simplify across from each other before we compute. So we're looking for a conversion factor that equals hours per minute. So all we're going to do is substitute in the right numbers. In this case, 1 hour is 60 minutes. And so we start with 100 miles per hour because that's what's given in the example, 100 miles per hour. And we're going to use 100 miles per hour times that conversion factor of 1 hour is 60 minutes. And then we're just going to multiply like normal with fractions. 100 times 1 is 100, and 1 times 60 is 60. Notice that the hours are across from each other, so we can cancel them out, and we're left with miles per minute. And if we go ahead and divide 100 divided by 60, we get 1.7 miles per 1 minute. So let's go down to the example at the bottom here. Please write this in your notebook. I've set up the problem for you here by starting with $1,742 and then per year, so that's your first one. And then we are going to find out how much is this per week. Well, the conversion factor that you need to know is right here. 1 year is 52 weeks. If you didn't know that, go ahead and make a mental note of that. That's something you should know. And now all we have to do is multiply straight across. Notice that the years are across from each other, so we can cancel those out. I could have put 52 weeks in 1 year. That's the same as 1 year over 52 weeks. But in this case, I wanted the years to be across from each other so I could cancel them out, leaving me with dollars per week. And so I have 1742 times 1 and 1 times 52. So all I have to do is take 1,742 and divide that by 52 to find my answer of $33.50. So go ahead and write that down here, $33.50. Going on to the next page, page 201, you have some more example problems. At the top of the page, we are going to be converting 176 feet per second, and we're converting that to miles per hour. So a couple of things to notice here. We're talking about 176 feet, and we're going to miles. So we're going from customary measurement to customary measurement. But then we're going from seconds to hours. And so there's a couple of different things you can do there. You can memorize that there are 3,600 seconds in 1 hour, or you can do that the long way and say that there are 60 minutes in 1 hour times 60 seconds in 1 minute. Notice how I wrote those across from each other so they could cancel out. And 60 times 60 is 3,600. So there are 3,600 seconds in 1 hour. And again, if you don't want to memorize that, I'll show you on the example problems how you can do that either way. So for 2A and 2B, go ahead and write these down in your notes. Okay, setting it up this way, starting with 320 kilometers. That's what was given to us in the problem. So I have 320 kilometers over 1 hour. It doesn't matter if you try to cancel out the hours first or the kilometers first. I chose to cancel out the kilometers first. Notice I did that by putting 1 kilometer in the denominator, and there are 1,000 meters in 1 kilometer. Now that I have my meters part of my answer, I'm going to change it to seconds. Okay, so I'm dealing with this hour right here. Okay, and to get that to cancel out, I put hours in the numerator, and I use the conversion factor that I know for 1 hour, which is 60 minutes. And I have to go one more step of putting 60 minutes in the denominator and canceling out with 1 minute over 60 seconds. Notice everything is canceled out here except for the meters and the seconds, which is what I want for my final answer. Once you've set up the problem, go ahead and use a calculator to multiply everything out. In this case, I can do some of it in my head here. 320 times 1,000 is 320,000. And then I'm going to divide that by 1 times 1 times 60 times 60, which is 3,600. My final answer is 88.8 repeating. So I can write that as 88.8 repeating meters per second. It doesn't tell me to round, and so I'll just write it as that. And let me go ahead and check my answer real quick. 88 and 8/9 is how they wrote it on the answer sheet, but that's fine. Either one is fine. Notice on 2B that I did a little bit differently. 70 miles per hour. I started with 70 miles per hour right here. Okay. And it doesn't matter, again, if you want to start with miles or hours, whichever one you want to convert, just either one is fine. I started with miles. There are 5,280 feet in 1 mile, and there's a reason I put 5,280 feet in the numerator, because I wanted the miles to cancel out, and they can't cancel out unless they're across from each other. Now that I've converted miles to feet, I need to change my hours to seconds. And in the first problem, I used 2 conversions, but in this problem, I just put 1 hour is 3,600 seconds. And again, there's a reason why I put the hour on top, so that it could cancel out the hour in the denominator. And I'm left with feet and seconds, which is what my question is asking for. So I'll pull up my calculator and take 70 times 5,280 in my numerator, and then divide that by 3,600 in my denominator. And I get 102 2/3, 102 2/3, and that's feet per seconds. And I'll go ahead and turn my answer key on, and that is the correct answer. Again, these are a little bit tricky. I will tell you I did not learn how to do dimensional analysis until I was in chemistry in high school, so I know it's a little bit tougher concept, but the more you do them, the more they make sense, and it's really fun to do them. So we'll do a couple more problems. Notice that you have on your note sheet the measurement conversions. I don't expect you to memorize all of these, but there's a couple that you will want to put to memory, including 1 inch is 2.54 centimeters, and let's see here, there's a couple other on here that we'll talk about. 1 kilogram is 2.2 pounds approximately. So just take a look at those, and you will have access to those if we're doing any of these on a test or an assessment. Okay. This next example is going to show customary to metric. So far we've been working in just customary or just metric, but we can also use dimensional analysis to convert between systems of measurements. And this is really common in a lot of appliances, or really anything that comes with a owner's manual. A lot of those manuals have to be both in customary and metric, because sometimes people from different countries buy the appliances and they usually use metric, whereas the United States uses customary. So one of my sister's first jobs in her engineering field was to translate, convert, if you will, from customary to metric in a lot of these user manuals that are used by people all over the world. So let's try one of these on page 202. 202, example 3, we're converting from centimeters to inches. So again, we're going from metric to customary. You can look through that example. There's that one conversion I told you should probably memorize. In 3B, this is not one of the conversions I have memorized, so you're going to have to just look at the chart to find out which one you need to use. For the examples, I've went ahead and written those in for you so you can copy these down for 3A, 3B, and 3C. And again, so once you write down the conversion factor, all you have to do is pull up a calculator and type it out. So once you have it set up, again, you're canceling them out, so you're left with the desired outcome as far as the label or the unit. In 3B, the ounces are across from each other, so we can cancel those out. And in 3C, we're canceling those yards out. So all we have to do is pull up that calculator. For number 3A, it's 9.65 kilometers. For 3B, 340.2 grams. And 3C, 10.05 meters. Finally, take a deep breath for this last one. It's a little bit long, but I know you can handle it. So we're talking about a problem where we're converting from metric to customary, and we're also dealing with the time. So you always start with the known, in this case 12 meters per second. That's where I started, 12 meters per 1 second. And you can either start with the measurement of length or the time, it doesn't matter. I chose to use seconds to start with to cancel out. And in your mind, just tell me why I put the seconds on top, 60 over 1, instead of 1 over 60. Okay, hopefully you said to yourself, the reason you use 60 over 1 instead of 1 over 60 is so that the seconds could cancel out. Okay, 1 over 60, 1 minute, over 60 seconds is also a correct conversion, but it would not allow us to cancel out our seconds, which is what we want to do here. Okay, so now we want to cancel out our minutes. So I have the minutes here canceling out with the minutes in the numerator. Okay, could you have combined the 60 and the 60 to put 3,600 over 1 hour? Absolutely. You could have skipped one of those conversions by just using this one. Either one's fine. Now, since I have my desired unit for time, which is hours, I'm going to work on this meters. So I'm going to jump over here, and there's a reason why the meters is on the bottom, so that the meters could cancel out. And there are 100 centimeters in 1 meter. Now, I use my conversion of 2.54 centimeters in 1 inch, again, so I can cancel out the centimeters. And then I need to cancel out the inches. So inches are in the denominator, inches are in the numerator, so I can cancel those out. And 1 foot is canceled out by using the conversion rate. 1 mile is 5,280 feet. I know there's a lot going on there, but it's very systematic in making sure that everything is able to cancel out so that we get to our desired outcome, which is miles per hour. And notice the only thing we have left here is miles and the hours. So now it just becomes a long multiplication problem. So we're going to pull up the calculator and take all the numerators, 12 times 60 times 60 times 100, and that is equal to 4,320,000. So let me write that down here just in case I lose it. And in the denominator we have 1 times 1 times 1 times 2.54 times 12 times 5,280. So we'll take 2.54 times 12 times 5,280 to get that. And let me see if I can expand that and put that to memory. And then I'm going to clear it. Oops, sorry about that. Memory and then clear. 4,320,000 divided by memory recall. That was not the right number. I'm not going to get the right answer, so let me take the denominator one more time. 2.54 times 12 times 5,280. 160934. And that's approximation. I already forgot the decimal place, but let's go ahead and continue. Divided by 160934, and we get 26.84. So 26.83 is the final answer there. I'm more concerned that you get this part down and really understanding why the placement is where it is. So again, that was a tough lesson, but it's something you can practice more of, and we'll do some more in class so that you can really get a firm understanding of dimensional analysis. Let me know if you have any questions.